We have been discussing about Java features, and I have already made we have already completed three sessions with Java features, right? So yesterday we have also completed yes, like robust, and this topic has been completed day before yesterday, and we have also completed why it is compiled and interpreted, multi-threaded, why it is multi-threaded. I have also given some explanation on this, and distributed, right? So the things that I am marking in yellow, the features that I am marking in yellow are already completed. So now we have to see why it is why Java is considered as the high performance programming language and why it is also called as the dynamic programming language. We will understand this too today, right? So let us understand why Java program is considered to be a high performance programming language. High performance. And these features are very important for the interview room, because there are high chances that at least one question will be asked out on the features, on the Java features. So we should be capable enough to answer it. So in order to answer it, we can answer that theoretically, but a little explanation could be appreciated. You need to explain it further. I mean, internally you need to understand why the features are described just like this. Right? Let us understand what is why it is high in performance. Right? So Java is considered to be high in performance just because it is using an hotspot in the JVM. Right? It is using what? It is using a JVM which is an hotspot JVM. So let me write that here. The performance is in Java because it is using a hotspot JVM. Right? Again, the follow-up question will be what is the hotspot JVM? Understanding is required, isn't it? The simple answer is JVM. We already know that we already know the acronym for the JVM. JVM stands for Java Virtual Machine. So the JVM which contains JIT compiler. The JVM which contains JIT compiler is called as hotspot. And now don't worry about this terminologies. I will be explaining it now. These are the simple line. I mean, these are the one-line answers. The performance is high in Java just because it is using hotspot JVM. Firstly. Secondly, you can also say that, what is again the hotspot JVM? The JVM which contains JIT compiler is called as hotspot JVM. And again, the follow-up question is going to be what is a JIT compiler? So JIT compiler stands for, it's an acronym that stands for just in time. Just in time. And again, what is a just in time compiler? I will be explaining one by one. No worries. Right. So let us understand this in understand this program in programmatically. So before even proceeding with this, so let me give you an high level diagram of the JVM. So let us say that this is a JVM, and again the JVM is going to take input from the compiler, and after JVM is going to convert the .class file into machine code or into the native code. So right, it is taking .class file as an input. We know these things already. .class file will be sent to JVM or will be loaded inside the JVM, and JVM is going to do some operation internally. It does something, and it is going to generate an output, isn't it? So even I can say that this .class file will be converted into machine code or the native code. So this is the input and this is output. And again, this native code will be interpreted and the output will be displayed in the console. So this is the JVM. Inside JVM, again the JVM is divided into several parts. JVM is a very complicated thing. And again, in future, we are going to have a big discussion on only specifically on JVM. So JVM internally is divided into many parts, right? One of the parts that we are talking about is what? JIT compiler. So JIT compiler is one of the parts inside the JVM that is available inside the JVM. Right? Let us say that this is the JIT compiler. Right? It is one of the parts inside the JVM, and the job of the JIT compiler is to ensure that it will make sure and it will take care of the hotspot situation. And again, what is the hotspot situation? Now we are going to see that. Right? Let's understand that. For example, I have a piece of code. I have a piece of code, and so this is my class. Let us say that the name of the class is test. And I have a main method. Public. Let us define a main method because execution always starts from the main method. Public static void main string array box. And inside the main method, for as of now, I am not defining any instructions. I am not keeping up any instructions inside the main method. So what I am taking another. I am taking another method, a user defined method. So let us say that the name of the user defined method is public static void method 1. It's a user defined method. So in this user defined method, just imagine that I have what 10,000 lines of code. I mean, we can say technically we can say 10,000 lines of instructions, just for the imagination. So we are going to have some instructions, and the instructions are counted. If when the instructions are counted, it is counting up to 10,000 lines. Let's say that 10,000 lines. Some random instructions. Okay. So method 1 has what? How many instructions? 10,000 lines of instructions. Right? Now, if I try to run this program, usually what happens? The program will be compiled first, right? First, it will be compiled. Before even compiling the program, we need to perform we need to follow some procedures. What is that? I already said it has to be saved with .java extension firstly. So in this case, test.java. After that, compilation. So compiler will ensure that the .java file will be converted into what? .class file. Again, this .class file will be sent to the JVM. And this JVM is responsible to perform the execution. So internally, it is going to convert the .class file into the native code or the machine code, and the output will be displayed, isn't it? So in the JVM, some things will happen in the JVM. The first thing is the main thread will be created. What thread? Main thread. The main thread will try to get access to the main method. Right? If you see inside the main method, is there any instructions inside the main method? There are no instructions inside the main method. So output is going to be empty. In this case. Right? But I want to execute this. I want to execute this method, which is method 1. I want to execute this method. In order to execute this method, I need to declare this method name inside the main method, isn't it? Because we already know that each and every instructions in the main method will be executed. That is the job of the JVM. JVM will not consider any other methods. It will consider only the instructions that is available in the main method. If you are defining any instructions in the main method, that instructions will be executed, and it will not consider the methods that is defined outside the main method, right? So in order to execute this method, I need to define this method. I need to call this method inside the main method. So I am going to call this method. How do we perform a method call? Usually we just call the method name and just empty parenthesis. Right, I have already said. Now the main method is going to be what? Caller method or calling method, and this method is going to be called method. So I am calling the method. Right. As soon as we have defined, the method is defined to be called, the control will be transferred from here to here. Now all the instructions inside this method one has to get executed one by one. Right. But how many instructions are there totally? We have redefined that it is estimated that there are 1000 lines of code in this particular method. Right. So what happens is we have just called only method, but that particular method, the typical method, has 1000 lines of code. All the 1000 lines of code has to be executed one by one, right? First instruction, second instruction, third instruction, isn't it? So what happens? The JVM is going to read the first instruction, right? Interpret, execute. These three operations will be done sequentially by the JVM. I mean by the main thread. Right? Reading is what? Read the instruction. Interpret means what? Interpret means, in this case, in this scenario, interpretation means converting the code into the machine code. Converting the line into the machine code. Read, interpret, execute. Right? The first line, read, interpret, execute. Again, the second instruction will be like, do the same, repeat the same thing. Read, interpret, execute. Right? Like this operation needs to be performed for all the 10,000 instructions, isn't it? Right? For all the 10,000 instructions, the main thread has to ensure these three operations. What are they? Read operation, interpret operation, and execute operation. Right? 10,000 times it needs to repeat the same thing over and over again. Right? No issues. And JVM will be very happy, because we as a developer, we are giving instructions, and it's job of the JVM, its responsibility to execute the instructions that we have declared. That is the job. No problem. JVM will be happy to execute all these instructions 10,000 times, and each and every time read, interpret, execute. Interpret is nothing but converting the code into the machine code. I mean zeros and ones. Strictly speaking, right? So this method call is over. What happens after executing the 10,000th line? Right, the control will be again transferred here. Right, and there are no instructions left to be executed. Right, then the program will be terminated. Main thread will be destroyed. Right, but the question is, if I'm trying to call the method one and for the second time, this is also possible. Right, second method call. First method call, the control will be transferred here, and all the instructions will be executed, and each and every time read, interpret, execute operation will be performed by the JVM. Again the control will be coming here. Now again we are it's method one, my mistake, my bad. Again we are trying to call the same method. Can happen, you can call a method many number of times, because method is defining a functionality. It is up to us if we are required to call that functionality over and over again because of our requirements, we have to call that method. So it is just consider that, and again we are facing a requirement to call this method once again. So again the second method call, again the control will go here. Again it is going to do the same operation, isn't it? Read, interpret, execute. Read, interpret, execute. Read, interpret, execute. Right? So if I am trying to recall the method for the third time, same thing. Like that I can call many number of times. Let us say that 10 times. Right? In Java 1.0 version, you must understand this. Hotspot is not there in Java 1. Now the hotspot is coming into picture. Hotspot as a hotspot was introduced in Java JDK 1.2. I mean hotspot JVM was introduced in JDK 1.2 version. 1.2 version. Right? So this job is being performed by the normal JVM. Right? But if you are trying to execute this code with the help of hotspot JVM, how the behavior is going to change, let's understand that. Right? So in the hotspot JVM, I have already said that it is going to have what? JIT compiler. Hotspot JVM, the JVM which contains JIT compiler is called as hotspot JVM. So far we have discussed about a scenario when the code is getting executed in the normal JVM. Right? So Java people has thought something. I mean, these things are getting. I mean, it is making the things complicated. Not complicated. It is taking a lot of time. They have like broken down an algorithm because they have thought when a code is getting repeated, or when a piece of function or when a piece of method is getting executed many number of times, right? For each and every time, for each and every line, every instruction, the read operation, interpret operation, execute operation is being performed over and over again, right? In order to avoid this, they have introduced the hotspot JVM. Right? So what hotspot JVM does? Now the scenario is like, let us assume that now we have an hotspot JVM. This is an hotspot JVM. Hotspot JVM. Right? So again, I'm going to call the method. So, and again, just it's a self-explanatory. And again, the main method is there, right? And the user-defined method is there, which is method 1. Same thing. I'm just keeping it simple. The main method, I'm calling this method 1. Right? So I'm calling the method 1 for let us say that 5 times. Method 1, method 1, method 1. Right? So hotspot JVM will start counting the execution. Right? First time when the method 1 is called, the method 1 is getting called for the first time, it will keep a count. It will keep counting. Hotspot JVM is going to count the number of times that a particular specific method is being called. Right? First time the count is going to be 0. Second time again the same method is getting called, count is going to be 1. Same method is getting called, count is going to be 2. Same method is getting called, count is going to be 3. As soon as it finds the method is getting called repeatedly, consecutively for the third time. So it will be in a situation to understand that, okay, this method is something important that is getting called repeatedly. So it is going to generate what? It is going to generate a native code. What happens? Now the JIT compiler will convert a native code. I mean, will convert the complete method code, convert the method, or we can say that we'll convert the total code into a native code. What does it mean? So just-in-time compiler is going to understand, okay, that so and so method 1 is getting called many times. First call, no problem. Second time, I mean, it is going to keep a count. Count number 0, count number 1, count number 2, and count number 3. This point is called as what? A threshold point. Sorry about my handwriting. I will be giving the clear notes. Just try to understand. This is a threshold type. Threshold. I mean, threshold is a maximum. I mean, it's a kind of unaccepted count, a kind of maximum count. When the threshold is reached, usually the threshold is 3. Sometimes depends upon the JVM. For some JVM, the threshold can be 4 or 5. Depends upon, it varies from JVM to JVM. By default, it is going to be 3. As soon as the count reaches 3, it is a threshold count. The JIT compiler comes into picture, and JIT compiler will do what? Will convert all this method 1 into a single machine code. Let us say that the machine code is 010101. Right? So what happens if this method is called for the 4th time or the 5th time? It will not encounter this read, interrupt, execute operation again, because the code has all the 10,000 instructions has been converted directly into a single machine code. Right? It is going to execute this code directly, and the output will be given. Hope you're able to understand. So this is a typical case. Let me use this case. Again, I am repeating. Right? I have, as I've already said, there are 10,000 instructions. An assumption, 10,000 instruction in the method 1. Method 1. Every time this method 1 is called, each and every instruction has to go through read. Each and every instruction I'm talking about: read, interpret, and execute. Let us say that each and every instruction is taking 1 second. So we have 10,000 instructions. It will take 10,000 seconds. For the first call, it is going to take 10,000 seconds. And again, if the method is going to be called for the second time, 10,000 seconds. Third time, 10,000 seconds. Fourth time, not 10,000 seconds, because the code is going to reach a threshold. JIT compiler is going to identify the particular code is getting executed repeatedly, getting called repeatedly. So let me create a native code for that. This time the whole method 1, a native code will be created for this whole method 1. At 4th time, it is going to take only 1 second. To call it for the 5th time, it is going to get a 1 second. Because we are going to avoid read, interrupt, execute operation for single lines. So for all the 10,000 lines, a specific native code will be generated. And if you call that for the 4th time, after the threshold is reached, it is not going to take 10,000 seconds. It is going to take only 1 second. You can, and if you going forward, if you at any point of time, if you are calling method 1 second it is going to take. This operation will be avoided. Because of this, the performance is going to be high. Just because of this. Okay, this is just a high level illustration for hyper. Why it is high performance? The simple answer is the performance in Java. The performance in Java is high because of the hotspot Java. Because it is using hotspot Java. The JVM which contains JIT compiler is called hotspot JVM. JIT stands for just in time. JIT is a part of the JVM, one of the components in the JVM. The purpose of JIT compiler is to it will count a particular execution or the particular method, and if a particular method is getting executed repeatedly, the JIT compiler will come to picture. The JIT compiler will come to picture, and JIT compiler will start counting the code, right? Like 1, 2, 3, 4. As soon as it reaches the threshold, threshold is something, it's a value. You can use that threshold anywhere. The threshold is like a English word is something like if a particular thing reaches a specific value, there you will take action. You say in college point of view, for example, if a student is doing mistake repeatedly, right, he will be getting some warning letters, and for those warning letters there will be a threshold. My college, there it was like that. If one person is getting 3 warning letter, he will be placed under suspension. The 3 warning letters are what? Threshold, right? Likewise, JIT has a threshold, and the count of the threshold is 3. Usually 3. It varies from JVM to JVM. By default, it is 3. Once a code is executed repeatedly for the third time, it is going to create a a situation called hotspot situation, right? And it will convert the total code into a native code, so that it can avoid this read, interrupt, and execute operation for all the 10,000 lines. So a single native code will be created, the performance will be increased. And I'm saying in any programming language, if the code get executed in less amount of time, what does it mean is the performance is always high. Both are inversely proportional. Reduce the time, increase the performance. Right? It cannot be increase the time, increase the performance. The relationship is completely opposite. Time is reduced, performance is increased. Vice versa. The performance is decreased. What does it mean? Time is getting increased. Execution time is getting increased. I hope you're able to understand these things. And if it is so, you can just type S in the chat box so that we can proceed further. Are you sure? You can ask me doubts, because you are. Please feel free to ask any doubts. Right? I hope I am going to continue the next topic, assuming that you have understood this. And you must be bold enough to raise questions. Whatever is not getting inside, must be bold enough to stop me, and you must be bold enough to raise questions. I hope you will do that in the future and going forward. Right? I'm not sure. And yes, I know my handwriting is very bad. No worries. I will be sending you a good notes. So the last topic is under the Java features is what? Now we have to discuss about dynamic. So dynamic is something it is self-explanatory, but still I will give you the high-level understanding of dynamic. Why it is called as dynamic? We have completed this high performance. You have completed. Let us understand why it is dynamic. Right. So before that, let me save this. For students. So why Java is a dynamic programming language? Java is dynamic programming. What is the online answer that anyone can give? Very simple. You can say that memory will be allocated on demand. Memory will be located on demand. This is the one point. Second point, we can also add this thing. Dot class files will be loaded. Will be loaded on demand. So what does it even mean? What are you talking about? Memory will be loaded on demand. Dot class file will be loaded on demand. Memory will be allocated on demand. Dot class will be. What does it even mean? You will understand this. Okay? Before even understanding this, let me know a small Java snippet. Right? So let me take the name of the class as class test. Right? And the public main method. Public static void main string array box. So I have a class test and I have a main method inside the class, contained inside the class test, right? I have already explained it many times. The execution will always start from the main method, and all the instructions in the main method will be executed. Right? My question is, how many dot class files will be generated? For example, I have a single class. The name of the class is test. In this case, if I start performing the compilation, one dot class file will be generated. Secondly, now my question is, I have another class, class A. Now, in this particular Java snippet, I have two classes, class test and class A, right? Now, my question is, how many dot class files will be generated? You can just type in the chat box. When I start compilation, when I start to perform the compilation, how many dot class files are going to get generated? Two. Exactly correct. Two dot class files are going to get generated. Yes. Let us check that. I will show you the folder where these dot class files are getting stored. Right. For better understanding. I don't know where it is. Okay, it's in C drive. I think it's in Java. I think. Okay. There are so many dot class files. So let me delete this. So this is, I mean, your focus required here. So I need to save the program, isn't it? So let me save this. I have saved this, and if you can see that, so it has been saved with the .java extension, and the name of the file is test. Why it is test? Because that is the main class. Why it is main class? Because the class that is holding the main method is going to be the main class. You know all this. This is the main class. You need to save the file with a particular class that is holding the main method. In this case, it is test, right? Now let me perform the compilation. So for the compilation, the command is javac space test.java. So it is compiled successfully. After the successful compilation, let me go back to the folder. Now you are able to see two dot classes, right? But when I try to perform the execution, right, only one dot class file will be loaded to the JVM. What I am trying to say is, let me copy this. Let me move this little above. Let me purchase some space. You are right. You have mentioned that how many dot class files will be? Two dot class files will be generated. You are completely right. But the follow-up question is going to be how many? I mean, whether these two dot class files will be loaded into the JVM, or is there any restrictions for that? That understanding is required here. What's happening there? I don't think I have covered it correctly. Okay. This one. Okay, let it be. So this is our code. Just assume that this is our code. So this is our code. Test.java. In this code, we have two classes. So this is what we have. We have class A and class test, right? So after compilation, we have concluded that two dot class files are generated. So in this case, what are the dot class files? Per our observation, we have found a dot class file, and we have also found test dot class file. These are the two dot class files that is generated. My question is, this dot class file has to get loaded inside the JVM. This is the JVM. After compilation, the next picture is what? JVM. This compiler. This is source code, and we have saved the source code as what? Test.java. Now two dot class file we have, right? So which dot class file will be loaded? Whether this both the A dot class file and test dot class file will be loaded, or is there any restrictions in loading dot class file? If you ask me question like this, I can simply what I'm saying is, I am concluding that only test.dot class file will be loaded inside the JVM. Only this dot class file will be loaded inside the JVM. This dot class file will be abandoned. Why, sir? Why this dot class file will be abandoned? If you ask me, the answer is very simple, right? So the execution starts inside the main method. Inside the main method, we haven't defined or we haven't instructed the JVM to work on, to transfer the control to dot class M, isn't it? For example, system.out.println. So this is main, simply for our understanding, I am saying main function. So the main thread will get access to the main method. This main function will get executed. The output is going to be what simply main function. And we haven't defined any instruction, any specific instruction where the control will be transferred to class A. Right? There is no such instructions. Or else, or something like, for example, to understand that, sir, I just want to confirm only the test.class file is getting loaded or not. In order to understand that, I have a simple trick to understand that. So there is a static block in Java. In Java, we have a block like static block. So what the definition says, static block says these blocks are recognized and executed at the time of loading the bytecode to the JVM. Self-explanatory. Static blocks are the blocks that are recognized and executed at the time of loading the bytecode to the JVM. And secondly, this is an important conclusion. One of the important conclusions. What, static blocks are executed first, even before the main method. Even before the main method. What does it even mean? So far, I have mentioned that all the instructions will get executed. All the instructions in the main method will be executed. Main method is the method that will be what? That will be recognized by the main thread, and all the instructions inside the main method will get executed. That is what our discussion and understanding so far. But this statement is something a contradiction. It's not a contradiction. It's something that we must focus on. Means this topic is not yet discussed. Now I am introducing this topic. What it says: static blocks are recognized at the time of loading the bytecode to the memory JVM. Secondly, static blocks are executed first, even before the main method. In this case, I haven't defined any static block. The output is going to be main function. Let us execute this. So compilation and execution. Output is main function. No issues, no doubt. So I'm going to introduce a block. The name of the block is static block. Static. In the static block, and just to make sure that this static block is getting executed, I am just mentioning a word, a simple instruction like static block of class test. Right? Your attention is required here. So in the test class, I have what? I have a main method, and I have, don't worry about static block. For the time being, just understand that static is just a block. Static is a keyword, and this is a block, and the keyword and the block is going to be static block. And you can keep some instructions in the static block, just like the main method. This is a prototype of the main method. This is static block. This is how the static block is going to look like. A simple static keyword followed by opening and closing parentheses and some instructions. Right? Usually what happens, again, let's think from the beginning. Let's think like a beginner saving the program. You have to save the program, and the dot class files will be generated, as we have seen already, right? And what the static block says, what the JVM gives importance to the static blocks first before the main method. It says These blocks are recognized and executed at the time of loading the bytecode to the JVM. What does it even mean? This is the bytecode. Test class is the bytecode. At the time of loading the bytecode to the JVM, static blocks will be executed. Then the main method will be created. What? At the time of loading the bytecode to the JVM, firstly static blocks will be executed. JVM will see if there are any static blocks or not. If there are any static blocks, firstly it will give preference to the static blocks. The instructions in the static block will be executed. Secondly, the main thread will be created. Secondly, what will be created? The main thread will be created secondly. And then the main thread will get access to the main method. Right? So far we haven't got any situation to introduce the static block. That's why I always used to say main thread will get access to the main method firstly, right? But in this case, we have a static block. What it says, these blocks are recognized at the time of putting the bytecode to the memory. Right? When the particular bytecode or dot class file is loaded, so bytecode is nothing but a dot class file. I know that you know this already. Bytecode and dot class files both are same. Right? In this case, test dot class file or test. We can also call this as bytecode. So now you answer me. If I run this code, what happens? Usually two dot class files will be created, right? Test dot class and a dot class. Right? And which dot class file will be loaded? Only test dot class file will be loaded, because that is test dot class file is having the main method, so the priority will be given to the test dot class file. This dot class file will be abandoned. This dot class file will be. While loading this dot class file, static, it will see if there are any static blocks. Yes, there is a static block. Execute this instruction while loading. Then main thread will be created, and the main thread will try to execute the information that is available in the main method. So can you tell me, can you guess what will be the sequence of my output now? You can type in the chat box. What the output is going to be, you can type in the chat box. Let me show you the program. Static block and main method. Which one will be the first? Which one will be displayed first? Static block of class test and main function, or main function followed by static block of class test? What is your amazing? Yes. So firstly, this will be executed. Let us run this program. Compilation successful. While running this code, so this is what happened. Static block of the class test. So this is the output. Let me copy the output. Let me copy the output. Let me paste it here. This is the output we got. So the static block of class test. So this is the output that we have got from the static block. It also means that this particular dot class file is getting loaded. Conclusion. In a nutshell, I can say that when you see this content, the content from the static block is getting executed. It also means what? It also means that that particular dot class file is loaded successfully. It means the test dot class file is loaded. Sir, I want a proof, because here we haven't defined any static thing. Here we have defined the static thing, so we are able to assume, or we are able to come to conclusion that test dot class file is loaded. Let me write a static block here also. Static block of class A. Right? So this is the proof. This is the proof that a dot class file is not getting loaded inside the JVM, because if it is getting loaded inside the JVM, this has to get executed. Let us see whether this is getting executed or not. Let me save this. Let me do the compilation once again. Let me run the code. See, static block of class test main function. In this case, this content inside the static block is not getting displayed in the console. The reason is a.class file is not loaded inside the JVM. Right? Why it is not loaded inside the JVM? We haven't instructed the main thread. I mean, we haven't given any instructions to transfer the control to the class A. No instructions are here to transfer the control to the class A. Sir, how do I transfer the control to the class A? If you ask me a question like this, either you can create object, one thing, create object for the independent class or the class that is outside the main method, independent class, or create an inheritance relationship or use this inheritance relationship. You can do these two things. Let us consider the first thing, which is create an object. An object of the class A. So in this case, I am creating object A to pj equal to new. Now the output will be very interesting. Java C compiled, Java testing. So now see static block of class A, main function, static block of class A. It is, I know this is going to be a little confusing. Let me explain this. Let us trace this program. You know what? This is one of the interview questions that I faced. I was giving an interview in the level 2 company. So they have given this code snippet. They have given the simple code snippet and they have asked me the output of this code. As simple as that. They have given a code like this and they have asked me, hey Balaji, can you predict the output? Can you tell me what the output is going to be? Right? So such an important concept. This is not even a concept. We are discussing this concept on top of the dynamic programming. I mean, why Java is dynamic programming language. And don't worry, for the static content, there is going to be a big class. Be very interesting. Static content. Now we are just discussing about the particular feature. On top of the feature, this topic is required for the understanding. That's why I introduced this. So this is the class, isn't it? Let us trace this. We know this entire code needs to be saved with what .java extension. After saving this with .java extension, it has to be sent inside. It has to be compiled. Compiler is required to perform the compilation. Compilation will do what? It is going to create two .class files here because there are two classes. For each and every class, compiler is responsible to create a.class and test.class. This .class files is also called as what? bytecode. After compilation, now the interesting part, JVM. Right? JVM. Now focus here. So JVM is coming into the picture. Right? What usually happens? By default, this test.class file will be loaded. Why the test.class file will be loaded? Because the main method is contained, or main method is existed in the test class. That's why by default this .class files will be loaded inside the JVM. Right? So this will be loaded inside the JVM. Right? While loading the .class file, while loading this .class file, JVM will make sure, JVM will check for the static content. If there are any static data, if there are any static blocks inside this test.class. Yes, there is a static block. Execute that, perform execution first. Execute the static blocks. That's what I said, right? Static blocks are recognized and executed at the time of loading the bytecode to the memory. Bytecode is loaded, test.class file is loaded. At the time of loading, very simple, at the time of loading, At the time of loading, execute the static block. Time of loading, execute the static block. Right? So static block will be recognized and executed here. As simple as that. Right? Now output is what? First output. Static block of class test. Right? So after recognizing the static block, the JVM will now it is going to create what? Main thread. Now main thread will try to get access to the what? Main method. So this is the main method. All the instructions inside the main method will be recognized and executed. The first instruction is what? Main function. So it is simple direct statement. Main function. This particular what we call it as word will be displayed in the console. As simple as that. Now secondly, after this, the control will be pointing towards, the main thread will be pointing here. Here what we are doing, we are creating an object for the class A. Object creation is happening. Object creation for class A. Object creation is happening for what? Which class? Class A. Isn't it? It means now class A is getting recognized. Recognition is happening for the class A. What about the object creation? In this case, object is getting created for class A. So the class A has to get recognized. In this case, now the dot class file of A will be loaded on demand. A dot class file will be loaded to the JVM because now it is required for the compiler to load the A dot class file to the JVM because we are creating object for class A. Now this needs to be recognized. Class A is nothing but A dot class. Now this will be loaded inside the JVM. Again, what I have said, when a particular dot class file is getting loaded in the JVM, the static content will be recognized. Right? What is the static content now? We have a static content class A. This will be recognized and executed. So the output is going to be what? Static block of class A. Static block of class A. Right? So what has happened here? The dot class files are getting loaded on demand. Only it is required the dot class files are getting loaded on the requirement basis. This is called as dynamic. This way it is called as dynamic programming language. If there is any requirement, then only I am going to consider that. If there is no requirement, what's the point of loading the dot class file here? If it is required, I can load that. The memory consumption can be sophisticated, advanced. This is how the memory consumption in Java is always sophisticated. Means unnecessary memory consumption will not happen in Java because everything is getting loaded on the demand. That's why it's called as dynamic programming language, because now I think there is a good justification for this line. Dot class files will be loaded on demand. So memory will be allocated on the demand. We have seen these things in the destructors topic in the previous class. Why Java is dynamic programming language? This is why it is dynamic programming language, because first point, memory will be loaded on demand and dot class files will be loaded on demand. How one can explain that dot class files will be loaded on the demand? This is the good example. Use the static blocks and you can give the explanation taking two classes. And just type as in the chat box if you have understood this topic. So this is the conclusion. Or if you need any explanation, you can